The unveiling of the CV90-120, a CV90 family vehicle re-engineered to carry the Rheinmetall L44A1 120mm gun, represents a potentially seismic shift in armored warfare design philosophy by bringing true main battle tank caliber lethality into what remains, in gross terms, an IFV-class package, a change with cascading implications across engineering, doctrine, logistics, procurement and operational art. Engineered solutions such as a reinforced turret ring, creep-strengthened hull sections, uprated suspension and transmission components, and a bespoke recoil attenuation and auto-loading suite have been married to the longer, higher-pressure L44A1 to manage the gun's impulse without imposing MBT-level mass. Those changes required compromises, decreased on-vehicle ammunition depth, tighter internal space management, and careful thermal and blast pressure control, but are offset by modern fire control hardware, multispectral sensors, advanced ballistic computation and battle management integration that together boost first-shot effectiveness and permit mixed ammunition tactics, APFSDS for armor defeat, programmable fuses for urban and anti-personnel effects, and guided munitions options for precision engagements. On the tactical plane, commanders see new possibilities. Mechanized infantry units armed with CV90-120S can conduct shaping and direct engagement tasks previously reserved for attached tank squadrons, closing with and defeating hardened positions or enemy armor more rapidly and enabling maneuver concepts that prioritize tempo and dispersion over massed armor columns. That flexibility might shorten kill chains. A forward platoon can designate and engage high-value targets at longer ranges, perform rapid flank interdiction, and provide persistent direct fire as units maneuver. But it also raises thorny doctrine questions about risk acceptance, target allocation, and mission command. Lighter platforms with tank guns are still not tanks in protection or sustained fire endurance, and using them as such risks exposing crews to counter-battery, anti-tank guided weapons, or attritional engagements they were not designed for. The logistics and sustainment picture is likewise complex. While acquisition and strategic lift costs could be lower than buying more MBTs, supply chains must absorb 120mm rounds and potentially more frequent drivetrain track maintenance as lighter power packs operate under heavier loads. Ammunition doctrine will likely favor tailored mixed loadouts and forward resupply methods to avoid the problems of low onboard depth. Market and geopolitical effects could be substantial. Countries constrained by budget, transport infrastructure, or difficult terrain may find the CV90-120 an appealing middle path. Nearly MBT-level punch without MBT logistical tails, and if adopted widely it could stimulate regional modernization drives and demand for countermeasures. Indeed, defense analysts warn of a likely near-term acceleration in active protection system deployments, new ERA developments tuned to defeat APFSDS, and more sophisticated anti-tank munitions designed to re-establish the advantage of heavy armor. Survivability for the CV90-120 therefore leans heavily on mobility, signature management, sensor networking, and combined arms integration, close drone support for reconnaissance and target handover, electronic warfare to blunt guided munitions, and soft kill APS to reduce incoming threats, rather than attempts to replicate MBT frontal armor. Training, doctrine, and command relationships will be decisive. Crews must be drilled in disciplined ammunition management, rapid target prioritization, and working within a larger combined arms framework so the platform's strengths are exploited without exposing its vulnerabilities. As prototype testing continues, user feedback is already informing incremental changes. Modular mission kits, scalable armor modules for different threat environments, options for unmanned or optionally manned turrets, and power pack upgrades to restore mobility margins, which will determine whether the CV90-120 becomes a niche stopgap or a disruptive class that reshapes force structure by making heavier punch more widely available at lower weight and cost. The vehicle's eventual impact will depend less on the hardware alone than on how militaries adapt doctrine, logistical practices, and procurement policies to manage the trade-offs. If they succeed, the CV90-120 could force a recalibration of the traditional tank IFV binary and change mechanized warfare calculations for a generation. If they fail to adapt, the hybrid may simply highlight the limits of trying to graft tank lethality onto a lighter, less protected hull.